Dear students, Assalamu alaikum warahmatullahi wabarakatuh. Today we will talk about the third lesson in Unit 1, which is called Physical Quantities, Scalars and Vectors. Firstly, we need to classify the physical quantities such as time, speed, distance, acceleration, and so on into two types: scalar physical quantity and vector physical quantity. Firstly, we need to know the definition or what's meant by scalar physical quantity and vector physical quantity. The definition of a scalar physical quantity, it says that it's a physical quantity has a magnitude only. To describe a scalar physical quantity or to know the scalar physical quantity, we need to know only its value, its numerical value, its number. As we said that the time of the journey is 3 hours. We need only to know the value, the number. But in the vector physical quantity, it is a physical quantity has magnitude and direction. We need to know the numerical value or the number and the direction, to south, to north, from A to B, from B to C. When I'm going in a trip and the starting point is A and the ending point is B, the starting point is the hotel and the ending point is the beach. There's a difference between going from point A to B or going from point B to A. In this case, the direction is different, while the distance is the same. The distance between the hotel and the beach is the same distance between the beach and the hotel, but the direction differs. When we go from the hotel to the beach, we go from point A to B, while when we return back to the hotel, we go from point B, which is the beach, to point A, which is the hotel. The examples of scalar physical quantity: mass, and its unit is kilogram; density, its unit is gram per cubic centimeter; length and distance, and both the units are meter, or it may be centimeter or kilometer. It depends on the distance. Time, second; speed is meter per second. When we need to talk about the vector physical quantity, its examples are force with Newton, force or weight, both are Newton; acceleration, meter per second square or kilometer per hour square, it depends on the distance and time; displacement with meter. We can notice that length, distance, and displacement, the three physical quantities, their unit is the same, meter, but length and distance are a scalar physical quantity, while displacement is vector physical quantity. And velocity, which is meter per second. Speed and velocity have the same unit. They may be the same in the magnitude, but speed needs only magnitude to be identified, while velocity needs magnitude and direction. And this is the difference between between the scalar physical quantity and vector physical quantity. When I ask you a question, give reason. Mass is scalar physical quantity, while force is vector physical quantity. Our answer will be because mass is identified only by using magnitude, while force is identified by knowing magnitude and direction. And now let's take two examples, one from the scalar physical quantity and the other from the vector physical quantity and talking about them and make a comparison between them. We will talk about distance, and firstly we'll talk about distance and displacement. Distance, its definition, it is the actual or real path between two positions. So when I'm moving from Cairo to Alex, the actual path is 300 kilometers. Displacement, the distance covered at certain direction. Now, in distance, we can say that we move 300 kilometers, but when it is a displacement, we need to say that we move 300 kilometers from Cairo to Alex. We need to specify the direction or identify our direction from the primary position, the starting point of movement, toward its final position. It is the ending position. Is the distance scalar or vector? It is a scalar quantity which has magnitude only and its unit is meter. While in case of displacement, it is a vector quantity which has magnitude and direction. Both of them are needed to describe the displacement, and its unit is also meter. We have an important definition. We have to differentiate between displacement and amount of displacement. What is meant by amount of displacement is the value or the length of shortest straight line between two positions. So this displacement, it is the distance covered from starting point to the ending point, while the amount of displacement, it is the length of the shortest straight line between two positions. Let's see an example to explain it more. When the body moves from point A to B and then to C, the starting position is A and the ending position is C. Let's see the difference between distance and displacement. Distance is the sum of both two distances, AB and BC, while the displacement is AC. AC is the shortest straight line, and we need to draw this arrow to say that we start the movement from point A and we end the movement at point C. It is not a straight line, it is a dashed line. Why? Because it is not real. The actual path is the distance. The actual moved length is the distance, while the displacement is the shortest straight line connect between the starting position and the ending position. And now let's talk about another examples, one of them from scalar and the other from vector physical quantity. Speed and velocity. The definition of speed, it is the distance covered by object in 1 second, while in velocity, displacement covered by object in 1 second. Both of them are similar, but here in the speed we use distance, but in velocity we use displacement. Speed is a scalar physical quantity which has a magnitude only, while velocity is vector quantity, has magnitude and direction. The unit of speed is meter per second or kilometer per hour, and also it is meter per second or kilometer per hour in case of velocity. Let's see the rule or the law of speed and velocity. The speed of the rule of speed is distance divided by time, or d divided by t, while in case of velocity it is displacement divided by time, or d, above it there is an arrow to identify the direction, divided by time, and the velocity there is an arrow above it because it's also a vector quantity. Don't forget, the vector quantities need magnitude and direction. Direction means it starts from what and ends at what. Let's take an example. If a body moves from point A to point B, or from point A to point C passing by point B, then returning back to point A. Calculate. Firstly, the distance covered by the body. Number 2, displacement done by the body. Number 3, the average speed and the average velocity. Let's start to answer. Distance equal the sum of all lengths. 20 plus 15 plus 25, because it moves from A to B, then from B to C, then from C returning back to A. 20 plus 15 plus 25 equals 60. Number 2, displacement equals 0. Why it's equal 0? Because there is no distance between the starting point and the ending point, as the starting point is A and the ending point is A2. So when the starting point is the same, the ending point, so the displacement equals 0. Average speed equals distance divided by time. Total distance divided by total time. Distance equals 60 and the time equals 15 plus 10 plus 5 equals 30. So it is 2 meters per second. The average velocity equals 0 because 0 divided by 30, which is the time, equals 0. And now we come to the end of our lesson by answering this question. Give reason. Pilots take in consideration the velocity of the wind. Pilots, before starting their trip, they need to know the velocity of the wind. Why? Because when the plane flies against the wind direction, it consumes more fuel than when it flies in the same direction of wind. It means that we have two options. The direction of the wind is the same direction of the plane, or the direction of the wind is in the opposite direction to the flight of the plane. When the wind is in the same direction, the wind pushes the plane and helps it to move. So it takes or uses less amount of fuel and it takes less time to complete the trip. But when the wind in the opposite direction of the plane, there's something which is called air resistance. This air resistance will try to decrease the speed of the plane, so the pilot needs to use more fuel to keep the speed of the plane constant. And so it takes more time to reach to the end of the trip by the plane. That was the last part in our lesson. Thank you so much and hope to see you again in another lessons. Goodbye.